Hello, my name is Hannah Young and I'm one of the co-authors of Deep Brain Reorienting. I'm going to read an excerpt from the chapter Affected by What, which is a case study we pieced together to give the reader a sort of immersive experience of the theory underpinning the approach. It's worth mentioning that at this point in the book, the reader has already been introduced to the superior colliculi, the orienting structures of the brain, the concept of shock and its hypothesized association with the locus coeruleus, and in this chapter, the affects and defenses that emanate from the periaqueductal grey. I hope that is enough to give you some grounding before I start reading this case study. Unknown to Mia, a friend is planning to physically assault her as part of a dare amongst their shared social group. Approaching them, she is expecting to be received and welcomed by the gang of youths. Instead, she quickly becomes aware of a look of malicious intent expressed on their faces. The unexpected has been identified by Mia's orienting system. She experiences a shock as if it were a blow to her upper chest. As we covered in Chapter 3, we use the concept of shock as potentially occurring before fight, flight, and freeze responses that are generated by the periaqueductal grey. Rigid and momentarily immobile, she scans their faces and listens intently for any clues as to the imminence of the threat. Her heart rate drops as she does so. Remember that from Chapter 3, this type of immobility, a vigilant rigidity and pre-affective freeze, is differentiated from other types of freeze, partly by its neuroanatomical activation. We consider that this primarily involves the superior colliculi, with a co-activation of sympathetic and parasympathetic nervous system arousal, mediated by the cuneiform nucleus. This places defensive action policies of the periaqueductal grey, for example fight and flight, on hold, while the threat's form and imminence are rapidly evaluated. Paradoxically, Mia experiences a simultaneous pull towards the group, most likely rooted in an attachment-seeking system, but with an urge to flee the situation. An orienting conflict between approach and avoidance at the level of the superior colliculi. We now follow the neuroactivation through the orienting layers of the superior colliculi and arrive at the periaqueductal grey. Recall that from earlier in this chapter, the initiation of defenses to confront or avoid threat is sensitive to the spatial and temporal dynamics of danger. This is why the proximity of a threat shifts activation to the defensive PAG from the cortical regions of the brain. In the Mobbs et al. Study, which demonstrated such an effect, activity in the periaqueductal grey correlated strongly with the subjective intensity of dread as a predator approached. Active defense responses of the dorsal columns include fight to confront the threat and flight to turn and flee. Their mobilization in Mia would be facilitated by the sympathetic nervous system effects of increased heart rate, blood pressure, and breathing. Vasodilation, including circulation of the hind limbs, prepares muscles for an effective motor escape in flight. Digestive functions are inhibited. The periaqueductal grey also possesses analgesic capacities, which include endogenous cannabinoids. Contrary to the drowsy effects of opioid-mediated analgesia, which are instead modulated by the ventrolateral columns, endogenous cannabinoids permit the mobilization necessary for active defensive capacities. The effect is one of dampening the fear response to promote adaptive action in the face of threat, and in modulating pain that may result from physical injury. The endogenous cannabinoids, as they block the escalation of fear, rage, grief, or shame, will also prevent the uninhibited stimulation of the sympathetic nervous system from leading to ill effects on Mia's physiology. It is too late to flee, however. Mia is already in close proximity to the group. They begin to surround her. She looks to the gang leader for safety and compassion. In young mammals and humans, one of the first defenses can be looking to or crying for the attachment figure during threat imminence, involving the panic grief system. Mia only finds indifference in her, however. A second shock. This time a felt drop from her chest to the deep abdomen. She has been abandoned to the subsequent savagery. Each member of the gang engages in hostile and false accusations. Mia is momentarily angered with an urge to fight. In the event of a perceived or actual social threat or insult, when our expectations are violated or when our basic needs are unmet, rage may ensue, involving the ignition of a fight response. Perhaps felt as a gripping of the chest and a building of pressure and heat in the body, rage shares a similar sympathetic signature with flight, but with increased blood flow to the face rather than the hind limbs. One group member grabs Mia's hair and she is trapped with her head held upside down. She freezes with high tonicity of the body. Much to the distress of those who have endured assault, a physical or sexual attack will not necessarily trigger a full fight or flight response. Its activation, however, is likely dampened by the actual or perceived inescapability of the situation, including the priming of defense responding, which has proven to be effective at promoting survival in the past. If the circumstances disallow such an exercise of agency, we are likely to freeze in a state of terror. Such tonic immobility can be brought about by physical contact with the perpetrator. And we suggest that it is mediated by a combination of dorsal and ventral column activation, as is the case in small mammals. Characteristics of both active and passive mechanisms manifest. The state of tonic immobility can be readily induced in animals who are trapped in a container and made helpless by its inversion. The co-activation of dorsal and ventrolateral columns can then be demonstrated. Although tonic immobility is more associated with sexual trauma in humans, it emerges in response to a range of traumatic events and involves hypertonicity of the body, alongside a sense of entrapment. There can be an urge to fight or flee without the motor release necessary for such movement. There can also be an urge to scream or shout or tell the attacker to leave me alone, but the distress vocalizations of the periaqueductal gray are not accessible during a tonic immobility state, a physiological fact which may nevertheless increase subsequent shame and self-recrimination. Mia suddenly collapses to the ground, losing momentary consciousness, not from the physical blow delivered by the perpetrator, but from shock combined with ventrolateral column dominance of the periaqueductal gray. Recall that contrary to the activation of the dorsal periaqueductal gray, which engages high arousal behavioral states of fight, flight, and freeze, the ventrolateral periaqueductal gray is involved in the full passive forms of defense. In cases of extreme trauma, as the dorsal columns of the periaqueductal gray become inactive, a ventrolateral passive defense response of collapsed immobility ensues. Animal models have demonstrated that this response is employed when the animal has been captured and restrained. As the ventrolateral column of the periaqueductal gray is a main area involved in micturition, it is possible that the inadvertent voiding of urine by a terrified individual may be a further reflection of the dominance of the midbrain to situations which inspire extreme fear. It could be argued that a shock in the body through, for example, a deep hemorrhage or other painful visceral event will first activate the ventrolateral periaqueductal gray. If it occurs in the context of an external event which is shocking, it is possible that there will be a combination of locus coeruleus activation and ventrolateral periaqueductal grey involvement in a state of sudden collapse with total loss of tone in the skeletal muscles. For Mia, this innate capacity for tonic immobility was primed by her early life in response to her mother's floridly psychotic episodes. Autonomically, there is withdrawal of the sympathetic nervous system activation, leaving a dominance of the parasympathetic nervous system, slowing heart rate and lowering blood pressure. The body is floppy and flaccid. The gang looks down at her in wide-eyed disbelief. She hardly touched you, they say. Mia picks herself up, stumbling away from the scene, disorientated. The world looks fuzzy, flat, and two-dimensional. Pain of a deep somatic and visceral nature recruits the analgesic capacities of the ventrolateral portion of the periaqueductal grey, including pain of a persistent and inescapable nature. Opioid-mediated analgesia is involved here and may induce numbness and altered states of consciousness, including amplification of shock-induced depersonalization and derealization. As Mia walks home, she finally weeps. There may be two kinds of sadness, activating and non-activating, and these overlap respectively with crying and non-crying. When there has been danger in expressing sadness, there may be a suppression of crying such that what appears to be a non-crying sadness is very much accompanied by dorsal periaqueductal grey activation of the sympathetic nervous system. When the sadness is of the crying or overtly activated type, it may be so intense that neurochemical dissociation, mediated by endogenous cannabinoids, is required. There are highly distressing non-crying states of internal activation, not only of the mesolimbic dopamine system, which is activated and negatively valenced, but also of the ventrolateral periaqueductal grey and its projections to the medulla for withdrawal of sympathetic nervous system activation. Deeply ashamed, Mia tells no one what has happened to her. Shame has often been assumed to be associated with parasympathetic nervous system breaking. However, rejection, physical assault, sexual violation, and social humiliation can all be viscerally painful, likely carrying a sympathetic nervous system activation accompanied by an urge to withdraw and hide. Shame can be potentially agonizing source of dysphoric mood and suicidal ideation. Mia feels utterly alone, oscillating between feeling the pain and shame of rejection and berating herself. How could I have been so stupid for trusting them? A fight response turned on the self. For those far enough away from danger, defensive rage may also emerge as associated with past trauma. Unfortunately, anger can fortify the individual against the underlying truth of emotional pain. Mia instead withdrew socially, emotionally, and physically from her environment. She became submissive and compliant in response to the needs and wishes of others. In animal models, after a period of intense stress, quiescent immobility is a state employed in which energy conservation facilitates healing from deep physical pain or social defeat. Primarily involving the ventrolateral column of the periaqueductal grey in humans, it may be related to the diminished seeking as evidenced in depressive and despair states in which the individual demonstrates hyporeactivity to the environment. Dominance of the ventrolateral periaqueductal grey can give rise to prolonged states of exhaustion or weakness, leaving a pervasive sense of hopelessness or lack of effective agency, imbuing the seeking system with negative valence. However, The social defeat animal model of submission to a dominant aggressor shows that the mesolimbic system is paradoxically in an activated state, even when the outside appearance is of low arousal. This is the reason that a non-nuanced use of the window of tolerance model can be misleading. It can miss important states of activated submission that appear on the surface to be hypoarousal states. Mia eventually sought psychotherapy for depression, severe anxiety in social situations, and for fear of falling, which she had not initially connected to the assault of many years previous.